Okay, so we're going to prove SAS similarity, which basically says that if you have it that the ratio of this side, right, to this side is equal to the ratio of this side to this side, and the angle between them is congruent, then the two triangles are similar. So how are we going to do this? What I'm going to do is I'm just going to make a nice little copy of triangle ABC, and let's say that that's the larger triangle. If the two triangles are the same side, the same size, then you have nothing to prove, because then it's congruent, and then of course it's similar. So what you're gonna do now is that you're going to go and you're gonna say that since this is the larger triangle ABC, right, what you want to do is you want to look at its corresponding side. So we're given that AB over DE, so it has to match with this one, okay, this one over here. And I'm going to say that this is point P, and I'm going to purposely make it that PB is the same length as DE, that these two are congruent. Now, once you have that, what you deliberately do, and you say that the line PQ is parallel to AC, and you could always do this. Okay, it's parallel to AC, and this is Q over here. Now, once you have that, you can state certain things. You could say that this angle over here is the same as this one over here, and this one over here is the same thing as this one over here, and of course they share this third angle over up there. Now, what you have with that is that then triangle PBQ is similar to triangle ABC. So from ABC is similar to PBQ by angle-angle similarity. Okay. Once you have that, you could start writing out that the sides are in proportion. So what's the statement of the sides being in proportion? It's AB over PB is equal to BC over PBQ is equal to AC over PQ. Since the triangles are similar. Now, once you have this, what you want to use is you want to use this fact. By your construction, you had that PB is equal to DE. So then that means that this is AB is equal to AB over DE. We should see that these are the same. This is the same as this. By my construction, I purposely made this length the same length as this here. So this whole thing will be equal to this whole thing, but then that means that this whole thing is equal to BC over BQ is equal to AC over PQ. And we should also see that in the given, I have that AB over DE is equal to BC over EF. So with that fact, right, this, if you write it on the other side of it, right, I have that it's BC over EF. And now everything is equal. If you look at these two, right, you should be able to see that then, EF is equal to BQ, right? This here says that BC over EF is equal to BC over BQ. And then that means the only way that this is true is if EF equals BQ. And obviously then EF is congruent to BQ. So then I have this. This is the same as this, that those two are congruent. Then what that guarantees is that triangle PBQ is congruent to triangle DEF by side. This side, the angle is the same, right? This angle I was already given. The way I constructed this was, so this angle would be the same. I mean, the way this was triangle ABC. I'm given that that angle B is the same as angle E. So then, of course, in triangle PBQ, this angle is the same as this one, which we were given that's the same as E. So by side angle side congruence, I have triangle PBQ is congruent to triangle DEF. And that implies similarity. And since I proved that these two are congruent, right? ABC is, sorry, not congruent, similar. Triangle ABC is similar to PBQ, and PBQ is similar to DEF with these two, right? This and this. I can conclude that triangle ABC is similar to triangle DEF, and I'm done.